Hey everybody, Mr. Regan here, and I hope that as we were thinking about our designs for our basketball players' wheelchairs, we were able to begin piecing together this relationship that force, mass, and velocity have. Now, whether we're talking about the wheelchairs for our basketball players or the space pod with our ground team, these three things affect one another and create what's considered a proportional relationship. And all that means is when one of these three change, it's going to affect how the other two work, or vice versa. So let's kind of look at that together. Now, one example of this relationship is whenever we have an object with a specific force. If I want to decrease the mass or make it lighter, I know that that force is going to increase its overall velocity or make it speed up. So the less mass I have on my object, the more velocity I'm going to have. So notice as one changes, others are going to change as well. In this case, the velocity. The opposite of that is then true. If I increase the mass of my object, that means this large force that I'm going to apply to it is going to have less of an effect. And then the velocity or the overall speed of the object is going to become slower, or it's not going to have as big of effect. And the same is true if I change the force. If I keep certain things the same, or if I change others, okay, those three things are all going to change as others do. And this proportional relationship is going to help us understand what's going on with our space pod. So the big kind of takeaway here, folks, is that if we have the same force exerted onto objects, but the masses are different, okay, the object with less mass is going to have a greater change in velocity. And that's something we're going to need to keep in mind as we begin to think what's going on with our space pods, and we pull in all of those key ideas. So, what are those key ideas? Well, number one is we know that as our pod approached our space station, what should have happened is the thrusters turned on, slowed our pod down so that it could dock. Okay. So a normal amount of thruster force should have slowed it down and allowed it to dock. That's one key piece of information we know. Okay. The second thing that we know is that our ground team is uncertain about whether or not there were a lot of asteroids with our space pod or if there were very few asteroids within our space pod. So we have these two big ideas. This is what should have happened, and this is what we don't quite know yet, or if we will ever know. So now we have to look back at our two sets of claims and really begin to think, how is it that these two claims could be true? Or in other words, what could be going on with the information that we know to help us explain how claim one here and how claim two could come to be? So we know that our space pod was approaching our pod or our station with a specific amount of velocity. A normal amount of thruster force was being used. Okay. And at that point, we lost sight of our space pod. Okay. We don't know kind of what happened. So we have our two claims. So during that missing time, missing communication time, we know that either the thrusters could have caused the pod to move in the opposite direction, or we know that the thrusters only slowed it but didn't stop it. So therefore, it would have hit that space station and bounced off. And then when our connection when we reconnected with our space station in our video, we know that it was then moving away. So we are going to have to figure out how we're going to use this information, how we're going to connect all these big pieces so that we can model to our space team, hey, based on what we know, here's what could have occurred. And we're going to be using our modeling tool to show how we could model claim one and claim two and how both of these claims could have come to be. So let's go ahead and look at how we're going to model these two claims. We're going to be hopping back into our modeling tool here. And if you notice, there's a few things we got to take into consideration as we build our model. We have our first row here that represents what most space pods should have done. So this first row represents this first comment, what should have happened. Okay. So what should have happened is that specific amount of velocity, we applied that specific force, and then it should have stopped and docked. Okay. But what we're going to do now is model our two claims, our pink claim and our green claim here, using this tool. So if you don't remember what the instructions are, or if you get to this modeling tool and you're confused, you can always go into the instructions and it'll kind of break down what we should do here. But what you're going to do is you're going to go into your features down here and decide, okay, if I'm looking at claim 1 here, the thrusters cause the pod to move in that opposite direction. I'm going to have to decide what object I should be using with the different masses, small, medium, or large, okay? Now notice this is what should have happened. Notice what objects we have in place here. Notice the force, notice the velocity, okay? So your job is to pick, okay, which of these objects should go into here based on the very first claim. So you got to think, in claim 1, what kind of mass would my object have, okay? And you'll pick your object. You'll need to add a velocity, thinking about what kind of velocity it should have. You're going to then use that same object, and you can drag and drop it here, obviously, depending on which one you think it is. Hopefully, we recognize it isn't all three. We should be using the same object for all three. You're going to then decide, okay, in order for claim 1 to occur, I have to apply the same force. Because remember, the force didn't change. So I know there's going to be a medium force. The question then is, what would my velocity be based on the object that I have? Okay, so we are trying to represent claim 1, so this pink claim, in our modeling tool here, okay? Deciding what mass it should have, what velocity it should have before and after the force, and then obviously what force it should have in our during box. When you think you have correctly modeled claim number 1 and what happened or what should have happened if claim 1 is true, you'd hit hand in, okay? After you do that, you're going to actually re-enter the tool using a different link, and then you're going to do claim 2. So the thrusters only slowed the pod, it didn't stop the pod. The pod hit the space station, which made it bounce off in the opposite direction. So now I'm going to, again, choose my object to represent what's going on with claim 2. Thinking about our asteroids, its mass, that sort of thing. I would model its velocity. I would add the force in the middle, and then I would model what the velocity is after that impact. And of course, I'd hit hand in again. So we're using the modeling tool to model claim 1 and claim 2, and then you're going to be using the next set of tasks to do just that. At this point, we should go into our slideshow and complete the survey. If you have questions or something didn't make sense or if you're unsure, okay, call me in. Otherwise,